Welcome back. In this video, we are going to learn how to write integration tests using test containers. We are going to create a sample Spring Boot application using Spring Data JPA and Postgres, and then we are going to write integration tests using REST Assured and test containers. But before jumping on to using test containers, first let us understand why should we use test containers in the first place. Let us go through some of the main reasons why we would like to use test containers for writing integration tests. So the first reason is problems with static integration testing infrastructure. So let us understand what it is. If you take any continuous integration system, be it Jenkins or GitHub Actions or any other system that you are using, let us imagine we are having a integration testing environment where you might be using Kafka, RabbitMQ or Postgres database. Let's assume you have a testing environment where you have installed Postgres database and RabbitMQ, and most likely you will have your build pipelines running for every PR or for every new branch that you are creating, and you want to run all your unit tests and integration tests that are going to talk to these services. So just imagine in one of the pipeline you are trying to insert a record, and in another pipeline another test is running where it is going to remove all the data from some table and then trying to insert some new records. So both of them are going to talk to the same table, and while one is trying to insert and assert there is a new record inserted, the other pipeline might be deleting the records from that, and so the results could be unpredictable. When you are running a single pipeline, it looks fine and everything, all the tests pass, but when there are multiple pipelines running in parallel, the behavior is unexpected because both of them talking to the same database, and maybe you are inserting one record using some use case, and then you are going to fetch the records and then assert, okay, there should be a number of records using this process. But meanwhile, parallelly, other pipeline also could insert some more records, and your expected count should maybe mismatch with the actual count. So there are these kind of issues can occur when you are running all your pipelines in parallel. Similarly, when you are using messaging systems like RabbitMQ or Kafka also, from one pipeline, while there is a test that is running where it is sending a message to your Kafka or RabbitMQ, and you are expecting one of your changes that is going to consume this and process in certain way and then store it in your database table. But the other pipeline, which is also running in parallel, might consume that message, and that pipeline might not have the logic to process it in certain way and store it into the database. So there is no guarantee that your pipeline is sending a message and your pipeline code is only going to consume that. There are other pipelines pointing to the same data, same queue. Maybe they will consume it and process it in a completely different way. So these are the problems that you may encounter when you are having a static and shared infrastructure for all your integration test pipelines. So this is one of the major problem. And second one is testing with real dependencies. As I said in one of my previous videos, we might be using databases, NoSQL databases, queue systems like RabbitMQ or Kafka, and some of them provide in-memory variations where you can use in-memory databases like H2 or HSQL and then test your repositories. But it is not, there is no guarantee that they are going to work in the very same way where you are using a production database like a Postgres or Oracle. There could be differences. And some services may not provide any such embedded or in-memory versions at all. For example, as far as I know, there is no in-memory support for Elasticsearch or Couchbase. So in such situations, there is no other way where you can run some in-memory process and then test your logic. So in such scenarios also, test containers is going to be really helpful. And one of the biggest advantage of using test containers is, like, in your local, while you are writing your production code and you are trying to write integration test, you can have the same experience. Like you can use Testcontainers API, and you can spin up whatever the containers that you want to run your integration test, and then execute your tests accordingly. And when you commit your code, the pipeline execution will be exactly same. So you don't have to blindly write your code and then commit your code to Git and then expect your continuous integration system run the test and then ensure, okay, whatever the code we have written is working fine. No need to wait for that long feedback cycles. You can write the test using test containers and immediately you can run, and it is going to be run exactly same as how it is going to run on CI. So you can have the same developer experience both on local and CI as well. One of the most important skill for a software developer is to be able to read the documentation and follow along and actually use the library or framework, whatever they are trying to learn. So we are going to do exactly that. So we are going to explore how to use test containers by reading the documentation or guides that are available on the Testcontainers website. So here, let us go to testcontainers.com, and there is a guide section over here, and here there are few guides available, and this is the guide that we are going to follow along, getting started with test containers in Java Spring Boot project. So now what we are going to do, we are going to create a Spring Boot application and implement a REST API endpoint using Spring MVC, Spring Data API and Postgres database. And then we are going to use test containers and rest assured for writing our API tests. So what are the prerequisites? We need to have Java 17 and one of your favorite IDs. I'm going to use IntelliJ IDEA, and this is the most important requirement. For now, let us use local Docker, because there are other approaches that you can use to run test containers based test, but let us go and start simply. So here I have installed Docker Desktop on my MacBook and it is running. So let us check, do we have all these requirements or not? So I have Java version 17, and let us check Docker info. Because I have Docker up and running, I am able to see this output here. So we are good to start. So what we need to do, we need to go to Spring Initializer and select Spring Web, Spring Data API, Postgres and Test Container Status. Let us do that. So here I am at start.spring.io and I am going to use maven build tool, and I am going to select the most recent Spring Boot version, which is 304, and here let me change it to com.SivaLabs, and here I'm going to name it as TC demo, test containers demo, and I'll keep Java 17 using jar packaging, and dependencies web and data JPA and Postgres database, and finally test containers. Okay, so like mentioned in the guide, we have selected Spring Web, Spring Data API, Postgres and test containers, and we can generate the application. So here I have imported the project into my IntelliJ IDEA, and I have opened the pom.xml here. Let us follow along the guide here. So we have all these dependencies and we have test containers bill of material configured. So here if you see, we have test containers bill of material configured, and we have imported PostgreSQL test containers module. And if you are using Gradle, you can see these dependencies like this. And now let us create a JPA entity. Let us create a customer.java. I'm going to copy this entire code snippet over here, and I'm going to paste. So this is one of the nice features of IntelliJ IDEA, where you have Java code in your clipboard and you can directly paste it, and it is going to create the file also. So cool. We have a JPA entity called customer, and we are going to store the data into customers table, and nothing much special, simple entity with ID, name, email properties. Let us switch back to guide. So next we are going to create a Spring Data JPA repository for the customer entity. Let us again copy this snippet, paste it, and we have customer repository also, which we are extending from JPA repository, so that we get all basic CRUD operations, create, read, update, delete, all operations automatically. Next we are going to use a schema.sql file. Basically you have various options to initialize your database. In production based systems, ideal way is to use either Flyway or Liquibase database migration tools. That is the preferred and highly recommended approach, but there are other options, like you can use data.sql and schema.sql, and you can enable to initialize the database on application startup. That is good enough for us to continue in this demo. So I'm going to create schema.sql file with this table creation script. Schema.sql. Next, we need to enable this initialization mode, otherwise by default it is not going to run this script. So let us configure this Spring SQL init mode always in the application properties file. So here let us go and add this property. Next we are going to create a REST controller to have one endpoint where we are going to get all the customers. Let us again copy the whole snippet. So nothing much complicated. Here we have a customer controller annotated with @REST controller, and we have injected customer repository, and we have a constructor. So in up to Spring version 4.x, I think we need to annotate with @auto-void. But if there is only one constructor, you don't even need to add this auto-void annotation. It will automatically use this constructor if there is only one constructor available. So we don't need to add @auto-void. So next we have only one endpoint where it is a get endpoint /API/customers, and we are going to fetch all the customers from our database and return them. So right now we have only one endpoint. Next, write test for API endpoint. So we are going to write a test to fetch all the customers using this endpoint, and we are going to use REST assured. Again, you don't actually need to use REST assured. By default, Spring Boot itself come up with REST template or test REST template and mock MVC, but it's a personal preference. Like REST assured comes with much better assertions, so I personally prefer to use REST assured. So the overall process is very similar, even if you use test REST template or web client, anything, but we are going to continue with REST assured. So let me add this dependency in pom.xml. Let me refresh. So next, this is how we are going to write integration test. Again, I'm going to copy this whole snippet and then walk you through what we are doing there. So under src test Java, I'm going to create this customer controller test. So first let us walk through the Spring Boot parts. While writing an integration test, we are going to use @Spring Boot test, as opposed to there are other annotations like @WebMVC test, @DataJPA test, which are used for slice testing. But here we are going to write integration test where we want to load the entire Spring Boot application context and then make a API call. So here we are configuring web environment is to run on random port, which is really a good option if you are going to run your tests on a pipeline, so that it is going to run the application on a randomly available port, so that even if there are multiple pipelines running, there is no conflict of ports. So we are going to use random port for running this integration test, and we are capturing what is the port it is running, because we mentioned it should run on a random port. We are injecting what is the port it is actually starting. It can be any randomly available port. And these are the interesting bits where we are actually using test containers. So test containers by default provides a generic container abstraction which you can use to start any Dockerized container. But to make it more useful and easy to use, test containers provides various modules for most commonly used services like Postgres, MySQL, Oracle, all these highly used, commonly used services. They have provided specific modules for it. That's why we have imported Postgres module and we are creating PostgreSQL container, because that's what we are going to use for our application. So if you are using MySQL, you should add MySQL test containers module, and you can initialize MySQL container. So here we are using Postgres container, and we can specify what exact version that we want to use for Postgres. So here is nothing but Docker image name and Docker tag. Because we are going to use 15 Alpine, I have mentioned Postgres 15 Alpine. And we mention it as a static property. It is an important thing to consider. And here we have a before all and after all JUnit callback methods, where before all runs even before running any of those test methods. So first we are starting this Postgres container using this lifecycle callback method, and we are saying stop it after executing all the tests. So this is a nice setup where we are starting the required containers before running our tests and then stopping the containers after execution of all the tests in this class. But our application usually in Spring Boot, if you want to talk to any database, ideally you should be configuring all those properties in application.properties or provide them through environment variables. But for running test, there is a provision where you can dynamically configure these properties. Even if you have configured spring.datasource.url username and password in application.properties, you can override them. If they are not configured, you can add them like this. So this dynamic property source annotation annotated method is used so that you can dynamically configure any of the properties. You can configure or override. So here, by using these lifecycle callback methods, we have already started the container, so that we can get this JDBC URL and what is the username and password. So usually you don't need to mention username and password because it doesn't really matter. We can go with the defaults and then ask for what is the username and password and configure these properties accordingly. So that now that we have our Spring Boot application running with the properties of data source configured, pointing to the container that we have dynamically spin up. Okay. So with that, we have the infrastructure ready, and we have injected our customer repository, which is a Spring Data API repository. And before running the test, we are configuring our rest assured base URL so that you don't need to repeat the whole URL for every test. We are setting up the base URL, which is localhost, and then port is a dynamic port which we have captured using @local server port. And before running all the tests, first we are cleaning up all the data. If there is any data in customers table, we are simply deleting it. And then we have only one test where we are creating a list of customers and we are not specifying ID because they are going to be auto generated, and we have couple of customer details here, and we are calling save all method on the customer repository because all these save all and delete, all these are provided using Spring Data JPA abstraction. And here we are storing 2 customers information into database table. Finally, here we are making an API call using REST assured. We are given a content type. When we make a call to API/customers, which is nothing but this API endpoint, then expect the status code to be 200, and we are asserting the number of items that we are expecting in the response is 2. We can go ahead and assert other details also, but to make the point here, we are ensuring just we get 2 records in the response, because we are deleting all the data. If there is any data, we are going to delete all the customer records, and then we have inserted 2 records into the customers table, and then we are making an API call which will go through this controller and then talk to repository and then fetch and return a list of customers. Testcontainers is going to provide a lot of logging information, so we are going to configure under src test resources. Let's create logback-test.xml, and then you can limit the logging of test containers to info, and docker java, which is being used behind the scenes by test containers, to warning, so that you don't get too much of logging. So once we configure this logging, let us go and run the test. So here we should be able to see the Postgres database being spin up, and then our application is going to run using that Postgres database. So here, if you take a look at it, Testcontainers is spinning up Postgres 15 Alpine container, and then configured our Spring Boot application to talk to that. And here we should be able to see the application is using PostgreSQL dialect and then executing the tests. So that is how we can use test containers to spin up whatever the application dependencies we have using Testcontainers API, and then test the application API endpoints. So here right now we have only one dependency, which is Postgres database, but if there are more dependencies like Kafka, RabbitMQ or Elasticsearch, whatever, in the similar way you should be able to create the containers and start them before running your test, and then run your test, and then stop your containers. Actually, you don't have to do this. By default, Testcontainers is going to take care of removing all these containers once the tests are done. Okay, cool. If you want to follow along the guide, you can go to testcontainers.com and go to guides and select getting started with test containers in Java Spring Boot guide, and you can follow along the guide and write your code and test everything. Or you can click on this get the code link, which will take you to a sample repository where all that code is already there, and you can import into your IDE and then run the tests. So it's up to you. So we have just learned how to use test containers for writing integration tests in a Java and Spring Boot based application. And if you come to testcontainers.org website, here you can see there is modules, and here it lists out all the modules that are already available. Like there are plenty of database modules available for most commonly used databases like Postgres, MySQL, Oracle, MongoDB, MariaDB. So most commonly used databases are already supported via modules. And then there are various other modules as well, like for running RabbitMQ or Kafka, or if you want to use a mock server or Red Panda. So there are dedicated modules available for most commonly used services already. And in addition to that, if you are not using Java and if you are using any other languages, there are other languages support as well, like if you are using Go or .NET or Python, Node.js. So there is support for those programming languages as well. We have just learned how to use real dependencies using test containers and run our integration tests, so that you don't have to use any in-memory variations of the databases or any other services. You can spin up a Docker container using test containers and run your test pointing to real dependencies. So with this test container setup, even if you are going back to our problem of using multiple pipelines, so here it won't talk to any of the central installed services like Postgres or RabbitMQ. Each pipeline is going to spin up their own containers, required containers, and use them, and once the testing is done, they are going to be automatically destroyed, so that no two pipelines will interfere with each other, so that you can run any number of pipelines, and each of the pipeline has its own set of dependencies as running as a Docker containers, and you can run any number of pipeline, and no pipeline will interfere with any other pipeline's container. I hope this video will help you to understand what is test containers and how to get started with test containers. And in the upcoming videos, we are going to make use of test containers for writing integration tests, even in a much more complex scenarios, like when we are having an application like this. Here we need to use RabbitMQ or Kafka and database, and then we may use Redis, and also we may have third-party services running. So we are going to explore how to use test containers to use mock server or wire mock and simulate these external API integrations, and also we are going to learn how to use RabbitMQ module or Kafka module and write integration tests for this event driven flows. So we are going to learn much more in the upcoming videos. So thanks for watching and stay tuned for the upcoming videos. Bye bye.